Hello everybody, we are back for another day of notes. Some of you might have already done these or started them on last year's notes, which are the identical, just new recording, that's all. So this unit we are doing kind of a little bit different, not really. This unit is just on exponents and radicals and dealing with like higher level exponents and radicals. So today we're going to be doing laws of exponents, so the rules that go along with them. And we'll do a little bit of application with it. Next class, we're going to be doing more application with it, where we have to use multiple laws in one problem. Okay? Then we will have like a quick review and a quiz that we're going to count as like half a test for it. Then we'll go into the radical part. So we're splitting it up so it's not one big test, but it's two little more manageable ones. Okay? So, well, let's go ahead and get started. Some of this might be review, because we're going to do a quick review. So we get 5x to the third. I just want to go over these different, the terminology to go with it. So the 5 right here is actually the coefficient. The x is the base. And the number that the base is raised to is called an exponent. And the whole thing all together is called a power. Okay? So please label this, and then we'll go on. Next thing, oh, wait, back it up. So we did all this. I think I forgot to scroll down, because there's definitely more on your paper. Let's find out. There we go. And then, oh, yep, I did. So then we have expanded form and exponent form. Exponent form is stuff that you guys are used to, just weird. A to the fifth, like, so using an exponent. Expanded form is writing it out by hand. So when we use, what is it called? Exponents, we're talking about multiplication. So it just means that we're multiplying the same number by itself 5 times, which is oh so much fun. So we use expanded, we don't use expanded form, we use exponent form to save us time and energy, because we work smarter, not harder. So then, now that we know that, there are laws that go with it. Okay? So we're going to be talking about these. That's the rest of this front page that you're doing. Law 1 is the product of powers. Okay? So it looks like this, where it's some base being raised to an exponent times the same base being raised to a different exponent, or the same number. What that has is that what we can do is we can say it's equal to that base and the exponents being added together. So when it's the same base being multiplied, we add the exponents. So here's an example. We have x to the 4th times x to the 5th, same base. We can add these exponents, so 4 plus 5. You just write it as x to the 9th. If you do this in the expanded form, you'd write out x's being multiplied like 4 x's times 5 more x's. So altogether there are 9 x's being multiplied. We just write it in shorthand. Okay? So that is the product of powers. Law 2, I can't talk. Law 2 is the power of a product. So that's when we have something being multiplied in parentheses, all being raised to one exponent. So the product is our base. Okay? What we do is we actually distribute that exponent to both parts of the product. Okay? So each part gets that exponent. So we just kind of expand it out. So it's a to the m times b to the m. An example would be if we had xy being raised to the 3rd power, the 3 gets applied to the x, 3 gets applied to the y. If you can simplify it further, go for it. Same thing here. Even with numbers, you could do the same thing. It's 4s being squared, so that 2 applies to the 4 and to the s. So we get 4 squared times s squared. 4 squared we can do. We know how to do that. So we just go ahead and do 4 squared is 16. So we get 16s squared. Okay? If you hear like random noises, it's my dog walking around. Nothing important, just my dog. Alright, so that is the power of a product. Okay, so just so you're aware, these the names of these laws, you don't need to worry about memorizing. However, the actual law itself, like the application of it, you do need to memorize what it looks like. Okay? And the names of these laws are very, very similar. Okay? but they describe what is going on. So here we have a quotient of powers, so it's literally the quotient division of two powers. Now, when they are the same base, we subtract the exponents. So same base, quotient means you're dividing. So quotient with the same base, we subtract those exponents. All right, here's an example. 2 to the 7th over 2 to the 6th. Yeah, you can go ahead and multiply it out or figure it out in the calculator. But if you know it this way, like same base, subtract the exponents. 7 minus 6 gives you 1. Anything raised to the first power is just that number. Okay? Another example, here's with variables where you can't just do it in the calculator. We have g to the 11th over g to the 4th. 11 minus 4 gives you 7. Okay? If you hear noise in the background, similar to music, that's my sister being very loud. Okay, so next one is the power of a quotient. So this is when the quotient's inside and the exponent is on the outside. So just like with the power of product, the quotient is going to be our base. We need to apply that exponent to both the top and the bottom. Okay, so we distribute again, just like with the power of product. Everything gets that exponent. Okay, an example, we have 3 over k all being raised to the 4th. The 4th power goes to the 3 and to the k. And then with the numbers, we can go ahead and simplify that. We get 81 over k to the 4th. All right. Power of a power. So when it's power of power, so 2 exponents but only 1 base. So here's a power inside the parentheses, the whole thing outside the parentheses, the whole thing is a power. We just go ahead and multiply these exponents. So when they're piggybacking on top of each other with nothing in between, we multiply. All right. Here's an example. So v to the 4th, all being raised to the 5th. We just multiply. 4 times 5 gives us v to the 20th. So negative exponents. A negative exponent just tells you that your base is in the wrong position, basically. So here it's in the numerator. It's just like a normal, it looks like a normal integer. That negative exponent says, hey, this should be a fraction. Okay, so what we do is we move the base and the number for the exponent down to the denominator and just put it over 1 or under 1, or whatever doesn't get moved, it just goes underneath. So a negative when it's on top, meaning it's in a numerator, it really means it's a positive on the bottom. Okay, it's a wrong location kind of siren going off. Same thing if it's a negative in the bottom, it's telling you it's in the wrong location. Okay, so you flip it around and you put it on top. Okay, and you're not doing a reciprocal of the fraction. Okay, so if there's other numbers involved, they stay where they are. Okay, it's only things that have a negative exponent that move. Okay, so here's an example. We have y to the negative 3. The y is in the wrong position, so that needs to move to the bottom. There was nothing else with it, so we just leave it. It's 1, basically, that was there with it. It was invisible. But with the y and the 3, it gets to the bottom. Once it's in the correct location, it goes back to being positive. Okay? Here's another one. We have 3 over t to the negative 2. T in the negative 2, that's telling you it's in the wrong location. So the t should actually be up here with the 3. And then once we move it, we can make it positive. It's happy then. It's not in the wrong place. Okay? Think of it like a crying baby. Oh no, I'm lost. Once it gets its parents back, it's happy. Alright? And then law 7. I know it's a lot of laws, but the more you practice it, the more you're not even going to think about it. You just know it. Okay? But a 0 exponent just means that anything with a 0 exponent, it's equal to 1. Not the exponent becomes 1, the whole power becomes 1. It's just 1. Okay? 3 to the 0 equals 1. 3v to the 0, v is the only thing that is raised to the 0 power, so that gets transformed into 1, so it's 3 times 1, which is just 3. Alright? Now, you are going to try these on your own. Okay? So, what you need to do is figure out which exponent. Now, since you have the actual terminology on the other side of your paper, you are going to go ahead. Here, let me show you all these. Excuse me. you're going to write down the law that you used, and you're actually going to apply that law. So write out what it's going to look like once you do that law to it. Okay? These are try on your own. Sorry, it printed very badly, so I'm going to leave this up for a second so you guys can pause on this page in case you can't read anything. So this is a 2 and a 6. This is a 6. This is a 5, a 9, a 10, a 2, a 9, a 4. This one's really hard to read on your paper. This is a 7. Okay, so W7 is what you get for E. A 10 on the top and then a 2 on the bottom. Okay, so you can pause the screen and that way you can reference it back. But that's, let me check, just make sure. Yep, that was it for your notes, so I'll scroll back. So if you want to pause it, go ahead right now. But other than that, I will see you next class. Okay? Bye! Oh, I keep saying bye, but I can't stop the recording because I don't have it. There we go. Bye!